In this video, we are going to discuss about the triangles. Triangles were introduced to you in your previous classes. Here we are introducing some of the important properties of triangles, right? So there are few points which we are going to discuss for this topic, right? The very first thing is the similarity and the congruency, right? We have understood the congruency of triangles in our previous classes. In this video, we are going to understand the similarity. We know what is similarity. Similarity is having similar things, right? Similarity is having something common, right? Same things are known similar. Two figures having same shape, okay? The shape is same but not necessarily the same size are called similar figures. For example, if you have a triangle like this and if you have a triangle like this, right? We can say that this triangle and this triangle are similar, right? So triangle A, B, C and triangle D, E and F, right? We can say ABC is similar to DEF. This is this symbol for similarity, right? And if they are congruent, it should be like this, right? For congruency, we know for congruency they must be of same size as well, right? If they are of same size, then we can say they are congruent. For congruency, we have gone through some of the criteria. For similarity also, there are some criteria. We'll understand that later, but the basics definition of similarity says that if we are having same shape, okay, if we are having same shape, they are similar figures, okay? They can be of same size, they can't be of same size. Size doesn't matter for similarity, but they should be of same shape. All the congruent figures are similar. We can say all the congruent figures are similar because they have same shape, okay? But the converse is not true. All the congruent figures are similar, but all the similar figures can't be congruent. We know that, okay? Because for congruency they must be of same size as well, right? For the polygons, right? If you are having a polygon, see, two polygons of the same sides are similar. If you have a polygon, right? This is a polygon, two polygons, right? Two polygons of same number of sides. The number of sides should be same. It's a quadrilateral. It's having four sides, right? It is also quadrilateral. A, B, C, D, E, F, G and H, right? How we can say that these two are similar? We can say that these two are similar if there are two conditions. The first one is this and the second one is this. Their corresponding angles, their corresponding sides are in the same ratio, okay? They has to be having the same ratio, not the same. The ratios should be same, okay? If they are having two corresponding angles, okay, corresponding angle, this is the angle and this is the angle, their ratio should be same, right? Similarly, the corresponding sides are in the same ratio, okay? There should be in same ratio, that is proportional. They should be proportional, okay? Now the third point is if the line is drawn parallel to one side of triangle, right? This you have studied, okay? This you have studied earlier also in your class 9th. See, when I'll draw the figure, you can easily recall that one, okay? If you are having triangle A, B and C, if I draw a parallel line here, okay, this is your parallel line, let it be E and F, right? This is a parallel line. This point is E and this point is F. If you draw, you say EF is parallel to BC, right? If you say EF is parallel to BC, now you can say this point divide the two sides into equal ratio. Okay, these two are divided in the same ratio. The ratio will be same, right? We can say that EA upon EB, right, is equal to AF upon FC. Their ratios are equal. If they are divided in 2:1 ratio, then this will also be divided in 2:1 ratio. So this is your important property, this one, right? This one is an important property. If we draw a parallel line, okay, opposite to one side of triangle, the other two will be divided in the same ratio, right? If a line divides the two triangle in the same ratio, okay, the line is parallel to the third side. This is just the inverse, okay? This is just the inverse of this one, okay? If the sides are divided in the same ratio, the third line is parallel, right? Now let us move forward and understand the criteria for similarity. Okay, what are the different criteria we have for the similarity of triangles, right? Let us draw a triangle here. Let this be triangle be A, B and C. We know for the similarity shape should be same. Okay, it is your D, E and F, right? So let us understand the first criteria, that is AAA, angle, 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 right? In congruency we have studied there is no criteria like AAA, but in similarity there is a criteria which is known as AAA, right? If angle A, these are the angles, three angles, right? If all the three angles, right, angle A is equal to angle D, right, angle B is equal to angle E, right, and angle C is equal to angle F, right? If it happens, then the two triangles are similar. Triangle ABC will be similar to triangle DEF. If this happens, if all the angles are equal. The second is AA, if any two, right, angle A is equal to angle D, right, and similarly angle E is equal to angle B, then also we can say that triangle ABC is similar to triangle DEF. Why we can say that? Because we know that the third is going to be equal. If these two are equal, then third is obviously equal. So by AA also we can say the two triangles are similar. Next is side, 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 right? If all the sides AB is equals to DE, right? If AC is equal to DF, right, and if BC is equal to EF, we can say that triangle ABC is similar to triangle DEF, right? Okay, similarly we have SAS, side, angle, side. If this side is sides are equal and this angle enclosing between these two sides, similar sides, right, we can say this and this are equal. This angle should be enclosed between the two equal sides only, then we can say it's SAS. If this is not equal and say these are equal, then it doesn't satisfy SAS, because angle should be enclosed between the two equal sides only. Okay, so we can say if angle A, if side AB is equal to any of the sides, okay, DE, and angle E is equals to angle B, right, and last is side BC is equals to EF, then also we can say that triangle ABC is similar to triangle DEF. Okay, these are just an examples only. Here what I'm writing are the examples only. There can be other sides also, right? You can take this side also if this side was equal, but you have to remember that angle should be enclosed between the two equal sides. So these four are the similarity criteria, and the fifth criteria is the right triangle. Okay, if we are having two right triangles with equal hypotenuse, we can say the two are similar. Okay. In a right triangle, the square of hypotenuse is equal to the sum of squares of two sides, right? This is Pythagoras theorem, which we have studied earlier also, right? We have studied Pythagoras theorem. Okay. See, if you are having a right triangle like this is just to recall you. You have studied our Pythagoras theorem earlier also. If this is your right triangle, what Pythagoras theorem says, this is the base because it's having the right angle. Okay. Now we can say the hypotenuse, the side opposite to the 90-degree angle, that is AB. AB square is equal to the sum of square of the other two sides. Other two sides are BC square plus AC square. Okay. So this is the Pythagoras theorem. For a right angle triangle, this will also always be satisfied, and this is known as your Pythagoras theorem. This was all about your triangles. Thank you for watching.